Alrighty, let's look at number 14. It's negative 3x to the fourth minus 8x cubed minus 15x squared minus 18x minus 8. And we want to find all the zeros and then factor it over the real numbers and over the complex numbers. So I'm going to start again with the rational zeros theorem. So to get our possible rational zeros, right, these are possible rational zeros. They're not all going to actually work. All right, so we have to find factors of the constant term, which is 8. We ignore the negative. And then factors of the leading coefficient, which is factors of 3. All right, so let's actually write these out. What are factors of 8? 1 goes into 8, 2 goes into 8, 4 goes into 8, and 8 itself. And then factors of 3, we have 1 and 3. Okay, so our potential rational zeros are going to be every combination of dividing these numbers. So plus or minus 1 divided by 1, which is 1, plus or minus 1 divided by 3, it's 1/3, plus or minus 2 divided by 1, which is 2, plus or minus 2 divided by 3, is 2/3, plus or minus 4, plus or minus 4/3, plus or minus 8, and then plus or minus 8/3. All right, so now let's graph it. Look at the calculator and see which of these actually does work. Okay. Alrighty, so go into y equals negative 3x to the fourth minus 8x cubed minus 15x squared minus 18x minus 8. Graph. Alrighty. That looks like negative 1. Let's check and see. Trace, negative 1. Yep. And that's the only zero we see. And actually, you can tell that the graph is coming up to the 0, and then it's coming back down, right? It's rebounding on the x-axis there. Remember, that means that it has an even multiplicity, so probably a multiplicity of 2, which means we'll be able to divide that number out twice. So we're going to take that negative 1, put it in our box for our synthetic division, line up our coefficients from the polynomial. You have negative 3, negative 8, negative 15, negative 18, negative 8. Leave some space and draw a line. Bring down negative 3. Multiply, we get 3. Add, we get negative 5. Multiply, we get 5. Add, we get negative 10. Multiply, we get 10. Add, we get negative 8. Multiply, we get 8. And then those cross off. All right, so remember I said we could do this twice, right? So let's do it again. Negative 1 in the box again, right where we left off. Bring down the negative 3. Multiply, you get 3. Add, you get negative 2. Multiply, you get 2. Add, you get negative 8. Multiply, you get 8. And there we go with those last two numbers canceling out. Now we can put the variables back into the problem. So we're down to a quadratic now because we started with the 4th degree and we divided out twice. So it goes down to 2nd degree. So we have negative 3x squared minus 2x minus 8. And we want to set this equal to 0 so that we can find the rest of our zeros. All right, now my preference is always to make the x squared term positive before I do anything else because it makes the quadratic formula work out slightly better. So I'm going to go ahead and divide by negative 1 everywhere. So that gives us positive 3x squared plus 2x plus 8 equals 0. All right, now the quadratic formula. Move this over a little bit. we're going to use the quadratic formula. So it's going to be x is equal to negative b, so negative 2, plus or minus the square root of b squared, 2 squared, minus 4 times a, which is 3, times c, which is 8, all divided by 2a, so 2 times 3. Sorry about that. I'll move that over. Okay, so there's our setup for our quadratic formula. If we simplify, we get negative 2 plus or minus square root of, let's work this out, 2 squared minus 4 times 3 times 8 is negative 92. All right, when you see a negative underneath the square root, that means we're going to have an imaginary number as part of this, okay? So anytime you have a negative under the square root, you have an imaginary number. And that's because, if you remember, that the square root of negative 1 is actually I. So we're going to break down this radical. What goes into 92? Anything good divide into 92? 92. Ah, yeah, 4 goes into 92. So what I'm going to do is I'm going to write this as the square root of negative 4 times the square root of 23. Oops. And that's because, 92 divided by 4 is 23. So that's a 2 over 6. All right, what is the square root of negative 4? Well, the square root of 4 is 2. So with a negative there, you just need to put an I. So it's 2i, and then we have the square root of 23 over 6. And then we can simplify this a little bit more. All right, so what we can do is divide all of these outside numbers by 2 just to reduce it. So that would be negative 1 plus or minus just 1 I square root 23 over 3, right? I just divided all of these numbers by 2. Alrighty, so that completes the process of finding the 0. So I'm going to write this out nicely over here. So we have is, we know that our zeros are negative 1, and then negative 1 plus I square root 23 over 3, and negative 1 minus I square root 23 over 3. Oh, this one has a multiplicity of 2. Okay, and that's going to be important when we build our factors. Right, these have multiplicity of 1. Okay, now let's go ahead and factor it. So we want to factor it first over just the real numbers. For that, the only real number 0 that we got was negative 1. These zeros are imaginary zeros, right, because they have I in them. So what we're going to do is build a factor for negative 1. That's going to come from x plus 1, right? But it has multiplicity 2, so we need to square it. We don't want to build factors for these for this part of the problem. Actually, what we want to do is go back to what we had before we ever solved for the imaginary zeros. So what we had here, we had a 3x squared plus 2x plus 8. Remember, we actually took a negative out of it too. So that negative that we took out, we need to put in front. And you can see that if you look back at the original problem, there was a negative in front, right? So we need that negative out there. So this is factored over the real numbers. And now if we want to factor over the complex numbers, we would build factors. So we'd still have a factor x plus 1 squared, but now we're going to build factors for this, what we got from the quadratic formula, actually. So we're going to have a factor that's x minus -1 plus I square root 23 over 3. And then a factor x minus -1 minus I square root 23 over 3, like that. And what do we need to put in front? On this one, we're going to have to put a -3 in front. That is the leading coefficient from the original problem, was -3. Why did we not have to put a -3 in front for factoring over the real numbers? How come we just put a negative and not the 3? Well, that was because the 3 already appeared here. So if we were to multiply it out, you actually would get the 3 in front of the polynomial. But down here, see, we just had x, x, x. We were missing that 3 so we needed to put it in front. Okay, and that's it.